Hello. Today we will discuss class C commutation. Class C commutation is also known as parallel capacitor commutation. Why parallel capacitor commutation? Because here we are using a parallel capacitor for commutating thyristor T1 and thyristor T2. This commutation technique is also known as complementary commutation. Why complementary commutation? Because firing of one SCR turn off the other SCR. That is, if you firing means if we turn on. If we turn on one SCR, it will turn off another SCR. That is, both these thyristor will work in complementary. That is, at a time only one thyristor will be in conductive mode and other will be in non-conductive mode, that is will remain turn off. That's why it is known as complementary commutation technique. Till now we have studied class A commutation and class B commutation, which were our current commutation techniques, because in those techniques we are actually reduce the level of current below the holding current value to commutate our thyristors. That's why those techniques were current commutation techniques. Now we will see in class C commutation we are actually using a voltage commutation technique. Voltage commutation technique, because in voltage commutation technique we actually reverse bias our SCR to commutate it. Reverse bias mean anode will be at negative potential and cathode will be at positive potential. If we just reverse bias our thyristor, it will be reverse bias, it will be turned off because of reverse bias. So here we are actually using voltage commutation technique. Now we will see in this circuit how will turn off and turn on various thyristors. In this circuit actually we have two thyristors, that is thyristor T1 and thyristor T2, and having a parallel capacitor, that is C, and two resistors R1 R2 and a DC supply. If we just switch on our DC supply, the current starts flowing, that is IL current starts flowing through the resistor R1 and through the thyristor T1. Actually T1 is triggered on first of all and T2 is in off mode, that is it is non-conductive. So T1 is turned on and the current starts flowing like this. The current also flow in the above circuit like this, because it will also flow through the resistor R2 and through the capacitor C and through the thyristor T1. Now due to this direction of current, the capacitor C will start charging. The capacitor plate B will be at positive potential and capacitor plate A will be at negative potential. Due to negative polarity of plate A, that is negative polarity at this node, the thyristor T1 will be reverse bias. That is, now the anode terminal of thyristor T1 will be at negative polarity. Due to capacitor polarities, these were the capacitor polarities, and due to these capacitor polarities, thyristor T1 now is reverse bias. Due to this reverse bias, it is actually happen when the capacitor will fully charged. Due to these polarities, the thyristor T1 will be reverse bias and it will turned off. Now it will be turned off. At this instant, due to positive polarity of capacitor C, the thyristor T1 will be turned on, and also due to the battery. So due to the conductive mode of thyristor T2, the current now starts flowing through the resistor and through the capacitor and thyristor T2 like this. The current also follow the path like this. So here we can see that first of all the thyristor T1 was conducting and T2 was non-conductive at that instant. Due to polarities of capacitor C, now thyristor T2 starts conducting and T1 is off. Due to this situation, now the polarities across the plates of capacitor changes. That is, now the plate EA is at positive potential due to the current flowing from higher potential to lower potential, and V will be at negative potential. Now due to the negative potential of the plate B, the thyristor T2 will be reverse bias. As the thyristor T2 will be reverse bias, it will turn off due to negative polarity of plate B. But due to positive polarity of plate A, T1 again starts conducting. It will again turn on. This process goes on. That is, if T1 is in conducting mode, T2 will be in non-conductive mode. If T2 in conductive mode, and at that time T1 will be at non-conductive mode. So both these thyristor will work in complementary. Now we will actually look up the waveform of this circuit. You can also look around the theoretical explanation of the above circuit, the actually working of the complementary commutation circuit. Now we will move towards this is the waveform of class C commutation technique. In the first waveform you can see that the thyristor T1 is turned on at this instant and thyristor T2 is turned on at this instant. If T1 is turned on, T2 will remain off, and if T2 is turned on, T1 will remain off. The second waveform is of the load current, that is IL. IL is the current flowing through the load, which is actually equals to the voltage B upon R2, the resistor through which current is flowing, or that resistor will be R1 actually. So load current is the current that is flowing through the resistor, that will be equal to voltage across it and the resistance which it is actually opposing the current. This is the load current waveform. As you can observe that the load current waveform is constant, that is current is continuously flowing through the resistor R2. Actually resistor, this one was our R1 and this was our R2. This was R1, this is our R2, here is capacitor, thyristor, and here we have another thyristor. So that was the circuit diagram. So resistor R1 through the R2 and R1, the current was continuous, that is current was continuously flowing through it. The third diagram is of current through the T1, that is current through the thyristor T1. In this you can observe that the instant up to this instant the thyristor T1 is actually turned on. So the total current flowing in the circuit is actually flowing through the thyristor T1. So here we can see that the total current actually flowing through the thyristor T1 during this phase. Now in the next phase you can observe that this is the current flowing through the thyristor T2. Here there is no current due to T1. It is empty here. So at this instant the current was flowing through the thyristor T1, and in the next instant you can observe that the current flowing through the thyristor T2 when T2 is turned on. So both will have complement currents, that is at first instant T1 was conducting, at second instant T2 was conducting. Now how these actually happen, as we have discussed in circuit diagram. This is our capacitor. Here we have capacitor A plate and we have B plate. We assume that here it is a plate A and it is plate B. As the current flowing through the thyristor is like this, the A will be at positive potential and B will be at negative potential. So till the A is at positive potential, this is the positive polarity of the voltage across the capacitor, the thyristor T1 is actually conducting. Now as the polarity is negative, as the polarity of the capacitor across the capacitor plate is negative, the thyristor T1 will be turned off and T2 is turned on, due to which, due to this negative polarity, T1 thyristor actually turned off, and this negative polarity actually treats T2 thyristor to turned on. So we can observe the positive and negative polarities of the capacitor C. Here Tc is the actual time during which the actual commutation process occurs. Here we can observe that various peaks. This is the peak current of T2. This is the small peaks in the current T1. These peaks actually occur as the time phase during which actually the commutation process is going on. During that phase, the current through the thyristor actually rise up. Heavy currents flow. Now the last waveform is of voltage across thyristor. You can actually leave that waveform, or if you can discuss here, you can see that the thyristor T1 has a voltage waveform during the T1 phase. Actually this is the T1 current and this is the T1 voltage. As the current flowing through the thyristor, the drop will be 0. So you can see that as the thyristor T1 is conducting, no voltage, no drop across it. That is, you can see from here, as the current is flowing in this phase, there is no drop, that is 0 drop. As it is turned off, the drop across the thyristor T1 develops. So this is all about the waveform of class C commutation technique.